Now coming to the group 16 elements itself, that is sulfur, we have discussed with you. That is sulfur dioxide, the reaction reducing properties, then bleaching action, the oxidizing properties. These all equations I have discussed with you. Got it? Just once you have a look of this particular equations, that is reducing properties of sulfur dioxide, then bleaching action of sulfur dioxide, then oxidizing properties of sulfur dioxide, so to say. Sulfur also forms several acids, that which I have told you already. Now we will come to the manufacture of sulfuric acid, but before going to the manufacture of sulfuric acid, some more things I want to show you which you have already discussed. That is this particular one, which you see the oxo acids of sulfur, the different structures of the oxo acids of sulfur which I discussed with you. You have to practice these structures you need to practice. Got it? You need to practice this all structures. Got it? The structure of the different oxo acids of sulfur, so to say. This I want to show you. You just see it properly, this particular part, and draw the structures accordingly. Draw this particular structures accordingly. Draw the structures. So you can see it is here. Sulfurous acid is there. Sulfuric acid is there. Then oleum, that is pyrosulfuric acid, is there. Then thiosulfurous acid is there, H2S2O2. Then we are having dithionous acid is there, that is H2S2O4. Then we are having dithionic acid is there, H2S2O6. Then we are having peroxomonosulfuric acid, that is Carose acid, H2SO5. And we are having peroxodisulfuric acid, that is H2S2O8. We can say that. Clear? So in this way we are having the different oxo acids of sulfur. We are having different oxo acids of sulfur. Got it? So that is, draw the structures. Why I am showing you this, that you need to draw the structures. You need to draw these particular structures. You take out a notebook and a pen and write this particular structures, draw this particular structures, and have a practice of this particular structures. Okay, I hope you have done it. This you have written it, you have done it. This particular structures you can find in your book also. It is being there, it should be there. Got it? And then we will come to the diagram, what you can say, flow sheet diagram. We will be coming to it, but before that we'll see the sulfuric acid, which is referred to as a king of chemicals. Sulfuric acid, it is also known as oil of vitriol, because it is being prepared from green vitriol, that is ferrous sulfate. In ancient times it was being prepared in this particular manner, so to say. We are preparing now sulfuric acid. We are preparing it, that is by what you can say, the contact process. We are preparing sulfuric acid. Clear? So this process, it involves, you can see the reaction, that sulfur reacts with oxygen to form sulfur dioxide, or that is ferrous sulfide reacts with oxygen to form sulfur dioxide, SO2. You can see it on the screen. Now SO2 further reacts with oxygen to form SO3. Got it? And it's an exothermic reaction. So when it forms SO3, it is not so easily it is being forming SO3. Got it? So what is that? You have to understand it. For that reason we are having a particular diagram, and we have to understand that particular diagram. We need to understand it. Got it? So we have to go through the several process of purification. A plant, it is used, and the name of the process is called as a contact process. A plant is used. Got it? And here we are having a different purifying unit. The different purifying unit is used for what you can say, that is purifying sulfur dioxide, which is then further converted into sulfur trioxide. Now this I am showing you here. You can see that the first we are getting, that is sulfur is being burnt in burners. We are getting sulfur dioxide. Then sulfur dioxide is being first passed into the dusting chamber. Now you can see it here. Here I am showing you, that is the different, we are having the different that is the purifying unit we are having. That is, A is your pyrite burners, where sulfur dioxide is being produced, and B is your dusting chamber, which I am discussing with you now. That is your dusting chamber, this one, dust chamber. So it makes the dust particles to settle down. How do we do that? We are passing water under high pressure, so that the dust particles settle down. Then we are having the cooling and the drying the tower, or the washing and the cooling tower also, it is being said to be as. Alright, you can see it here, the dust filter chamber, that is number B. And C, there is the dust filter chamber, and B and C, you can see that. So there what we do is that the dust free gases, the first, the dust particle is allowed to settle down in the dust precipitator, in the what you can say, in the dust chamber. Got it? Then we are coming to the dust filter chamber and the washing tower, we can say that, where the dust free gases are washed with water to remove the impurities and to cool the gases. Got it? The dust free gases are washed with water to remove the impurities and to cool the gases. That is in B and C, it is being done. Got it? Then we are going to the drying tower. Now see, after passing through moisture, the gas becomes moist, we can say that. So in this tower, the incoming gases are dried by spray of concentrated sulfuric acid. Got it? You can see it here in the D, that is your drying tower. The incoming gases is being what you can say, sprayed by concentrated sulfuric acid, where the gas gets dried, that is sulfur dioxide gets dried, we can say that. Got it? Then we are having the arsenic purifier, we can say that. That is the arsenic purifier we are having here, that is arsenic purifier. See after that, so here the arsenic purifier is being not shown here, just I am saying you. In the arsenic purifier, what is being done, it consists of a gelatinous ferric hydroxide which absorbs any impurities of arsenic oxide present in the gases. Any impurities of arsenic oxide, if it is there, because that will make that is sulfur dioxide poisonous if arsenic impurities are being there. Then what we do is that we pass it through a testing box. This is a testing box, you can see it here. In the testing box, what happens is that this box detects the presence of solid particles in the incoming gases. When the gases are found to be free from solid particles, they are allowed to move onwards to the contact tower. Alright, how do we do that? In the testing box, it is a brightly illuminated box. The testing box is brightly illuminated box, and when the sulfur dioxide gas is passed into it, we come to know any dust particles is floating in it or not, any solid particles is floating in it or not. Alright, we come to know from there. Then it is being passed into the, what you can say, you can see it is being passed on the preheater and to the catalytic converter. Got it? The preheater, we heat it first. Preheater, that is, we heat it first with little bit. Then after that we pass it to the catalytic converter, that is the contact chamber, we can say that V2O5 it is being packed with. The contact tower, it consists of iron pipes packed with vanadium pentoxide, that is V2O5. The gases coming out of the testing box are heated to 725 Kelvin, I said you, in the preheater first, and then allowed to enter into this particular tower. Got it? The mixture of sulfur dioxide and air passes through the pipes containing the catalyst. Sulfur dioxide gets converted into sulfur trioxide here, SO2 to SO3, and the reaction is exothermic, so further heating is not required. The heat which is being released, that only maintains the reaction forward. That keeps the temperature and maintains the reaction, temperature of the reaction, we can say that. Therefore, once the process has started, the gases are not heated in the preheater and pass directly into the contact tower. Then we come to the absorption tower. You can see the absorption tower, SO3 is being produced here in the catalytic converter, and it goes to the absorption tower. You can see it here. Absorption tower is your F. In the absorption tower, the sulfur trioxide formed in the contact tower is now what you can say, led to the absorption tower, where it is brought in contact with concentrated sulfuric acid, which reacts with concentrated sulfuric acid from the top of the tower. I can show you the reactions here. The reaction SO3 plus H2SO4, it forms oleum, and this oleum further reacts with water to form sulfuric acid, H2SO4, last equation. Got it? So here in the absorption tower, first it reacts with concentrated sulfuric acid to form oleum. Oleum further reacts with water to form sulfuric acid, so to say. Now directly, why we are not converting SO3 to H2SO4? The reason is that SO3, when it reacts with H2O, it forms vapors of sulfuric acid, and it's very difficult to condense these vapors. Or it forms a cloud of sulfuric acid, and it's very difficult to condense this particular cloud or the vapors of sulfuric acid. So hence it is not being done. First it is being converted into oleum, then it is converted into sulfuric acid. And economically it is advantageous for us, because you can see we are taking 1 mole of sulfuric acid to prepare oleum, but we are getting 2 moles of sulfuric acid as a product. We are taking 1 mole of sulfuric acid to prepare oleum, but we are getting 2 moles of sulfuric acid. Got it? So it is economically, it is advantageous for us. Got it? Now in this way, you can see this is your structure of sulfuric acid. You can see it here, tetrahedral structure. I have shown you here the structure of sulfuric acid, clear? And these are the chemical properties of sulfuric acid. Sulfuric acid reacts acts as an oxidant, what you can say, dehydrating agent. You can see if you take sugar, like suppose you take a test tube and you add some sugar into the test tube. Got it? Sugar, simply sugar, which you are using in your house. Then you add some concerned sulfuric acid, few drops. You will see it forms a black mass. Got it? A black fuming mass is being formed. What is that? And after that, when the mass subsides, water is being released, you will see black specks of carbon sticks in the inner walls of the test tube, which proves that concentrated sulfuric acid acts as a dehydrating agent. It removes the water molecule which is being present in sugar. Alright, it removes, so it acts as a dehydrating agent. Similarly, if you take oxalic acid, you can see water is removed, you get carbon monoxide and carbon dioxide. Ethyl alcohol also same thing, it forms ethylene and water when it reacts with concentrated sulfuric acid at 343 Kelvin. You have studied in the lower classes. Similarly, when sodium bromide reacts with sulfuric acid, it forms NaHSO4, SO2 and Br2 and water. And when the lead acetate forms white precipitate of lead sulfate. Benzene, when reacts with concentrated sulfuric acid at 330 Kelvin, it forms benzene sulfonic acid. Sulfuric acid, when reacts with PCl5, it forms chlorosulfonic acid, POCl3 and HCl. We can say that chlorosulfonic acid. Similarly, when it reacts with salt, sulfuric acid, you can write it down, this reaction. NaCl plus H2SO4 gives NaHSO4 plus HCl. KNO3 plus H2SO4, which gives KHSO4 plus HNO3. FeS plus H2SO4 gives FeSO4 plus H2S. Got it? NaI plus H2SO4 gives NaHSO4 plus SO2 plus I2 plus water. Again I repeat, NaI plus H2SO4 gives NaHSO4 plus SO2 plus I2 plus water. Similarly, concentrated sulfuric acid oxidizes metals like copper, lead, mercury, etc. first to their oxides and then to the sulfates. Got it? That is, copper plus H2SO4 conc will give you copper sulfate plus SO2 plus water. Copper sulfate plus SO2 plus water. Zinc, iron, tin, manganese, etc. gets oxidized even with dilute sulfuric acid also, because they are placed above hydrogen in the metal activity series, so they can be oxidized by dilute sulfuric acid. But copper, lead, mercury, they are oxidized only by the what you can say, this concentrated sulfuric acid, we can say that. Clear? Now sulfuric acid, what you find is that it reacts with SO3 to form oleum. You have seen it already. It reacts with barium chloride to form barium sulfate, a white precipitate like lead sulfate, we can say that, and HCl gas is being produced, we can say. So these are the different reactions of sulfuric acid, we can say that. Thank you.